Question number 13. Standard combustion enthalpies of hydrogen, carbon and methanol at 298 Kelvin are minus 286, minus 393 and minus 726 respectively. Enthalpy of vaporization of methanol liquid is plus 37. Enthalpy of formation of 1 mole of gaseous CH3OH. So they have highlighted this term gaseous. So that means we have to write down the formation enthalpy reaction for the gaseous methanol. Say CH3OH gas. So we have to produce that from the constituent elements: carbon solid, hydrogen gas and oxygen gas. Now let's balance it. One carbon here, so one carbon here. There are 4 hydrogens, so we have to put 2 here. 1 oxygen, therefore we have to put half here. So this is the enthalpy of formation of gaseous methanol. Enthalpy of formation. And they have said the combustion enthalpies are also given. So we have to combust them. O2 gas and O2 gas. When we balance this, before balancing it, we have to write down the combustion products. It's carbon dioxide and H2O liquid. So carbon is 1. There are 2 hydrogens, therefore 2 water molecules should be produced. The combustion enthalpy of carbon is minus 393. So this value is negative 393. Then the combustion of H2 gas is minus 286, and there are 2 hydrogen molecules. This will be the combustion of 2 H2 molecules. And they have given the combustion of methanol liquid. So it's not the gas they have given, so we have to write CH3OH liquid plus O2. We didn't balance it. Let's try to balance that. The carbon amount is balanced, hydrogen amount is balanced. Now the oxygen amount is 4 here, so we have to make the oxygen 4 here. So let's put it's balanced. 2 oxygen plus 1, it's 3 oxygen, so we have to put 1 here. Yes, 3 over 2 and 3 over 2, so it's 3 and plus 4, right? 3 over 2 here. Now this value is also given. This is the combustion enthalpy of CH3OH liquid, and it's given as negative 726. And this value is also given, that is from liquid to gas is given, this part. It is the enthalpy of vaporization of methanol. It's plus 37. Now please remember, now when we try to apply the Hess law here, you have to find the same reactants and the same products, but by looking at this chart we cannot find that. We have to make let's say this one, we can inverse this value here. We can change the direction of the arrow and make this a plus value. So let's do that. Now we are just eliminating this whole thing, and we are putting the arrow backwards and making the sign plus 726. Actually, this is also a scientific law. That means if a particular enthalpy is negative in a particular direction, the same reaction backwards will have the same enthalpy value but the sign inversed. So it's called the Lavoisier and Laplace law. But that's not in the syllabus, but you should know that we can do that. So we found our same initial reactants and same final products. So we have our two pathways. This is our first pathway, this is our second pathway. So according to the Hess law, say by Hess law, whatever the pathway that it takes, the enthalpy change doesn't change. The enthalpy change is always the same. Therefore, delta H naught F equals the sum of all the enthalpies in this second pathway. This is our second pathway, this is our first pathway. So negative 393 plus I'll just multiply this negative 572 here and plus 726 plus 37. So if you calculate this value, we will get negative 202 kilojoules per mole. So this will be our answer. So the answer for the 13th question is third one. Okay, let's move on to the next question.